Share screen. Screen 2. Yep. All right. I wonder if it still has my code from yesterday in there. It does. All right, cool. So we can talk about that again. So what I want to do is just make an object-oriented variation of kind of what Alita did and even a little bit of Evan did. So again, the idea here is saving it. Now, I did want to clarify that I did think about it later and realize that if we did remove the duplicates out of our examples, then technically our indexes become one off from what we want. So I may not actually need to do the object variation of it. In order to store these, I could just go this direction and just use the index I'm on in order to keep track of it. So I might not actually need to save the rank. I could just use the indexes if I'm removing the index, if I'm removing those. But since I didn't put that in my computational logic, I'm not going to do that. I'm going to create what I said I was going to create in the computational logic, where I want to keep track of these scores. Since I didn't realize that the rankings could be the indexes minus 1. So I didn't realize that during my computational logic. I'm not going to do that now. I can showcase that at the end of the quick one if we have enough time if you want to see it. So what we're going to try to do though is create, like I said, is create an object that stores the rank of each score, remove the duplicates, turns this array list into something that looks like this kind of list. That doesn't exist. That way I can loop from this direction that way. So drawings. So I can take the object-oriented approach. I created a simple object called ranked player. This player, a ranked player, has a score and their rank associated with them. All you do now is convert this list of ranked people into a list of ranked players where only the individual, the unique items are. So I can first create the list. So we got our list of ranked players. So this is a list that's going to take a data type called ranked players. Now I'm going to loop through my ranked items and add them each. What I can do first, though, is I want to get my first item because I want to make sure I can compare against it. So I need int score equals ranked. Get right for list, right? Yeah, it's 0. With that, I'm also going to do player put, right? Oh, I can do dot add, yeah, on a list as well. So add, in this case, I'm going to add new player. Let's see what we did, score rank. Okay, good. So I can do current score. Which I should probably keep track of that actually. I might not need this variable. For now, I'll keep the variable just so that I can see it. Do I need this or not? We'll keep this here for now. I might need it. So by adding the first person in there, now I have a way to compare to see, am I having the same one? Is the second place, is the second person in the list the same as my first? Instead of trying to compare against some number that doesn't exist. Remember that in Java, I can't really set a number to null and int starts at 0. So I can't really compare against it. So I gotta be careful on that. So now I can do for int r score. Right. If r score not equal current score. So if my r score is not equal to my current score, I can assume we've gone down, right? That this score now is lower than my current score, right? Is that a safe assumption to make?
No.
Why?
No.
If the R score is not equal to the current score, so the score I pull out of ranked is not equal to my current score, which I set to the first one anyway, so it's automatically set to the first item, can I assume that R score is lower than current score?
No.
Why?
Because just being not equal, it could be 101 over 100.
It could be. I thought that we were told that this rank is always going to go down. But it's already sorted in a decrementing array, right? The existing leaderboard ranked is in descending order. There's no way for a item after the first one to be higher than it, right? So I already have this stored in my current score. There is no logical way for any number this way to be higher than my first number, right?
Right.
If you don't remove the duplicates.
It won't be lower though. If
No,
it's not
I
equal to, it'll
understand.
be lower, right?
I agree with you that if you don't manipulate that array,
Mhm.
then that will stand. But once you manipulate it, you have to resort it.
But I haven't manipulated it.
I know I just made that statement.
Right, but no, again, so my point again though is just saying, based on what I'm doing here though, I can make that logical assumption that if that the score I pulled out of rank, too far, this array is not equal to my current score, it has to be lower than current score, right? It can't be higher than it, right?
No, I mean, it could be because you could have well, no, actually it won't, because your player score is going to be at the lowest one because the way it's working.
I'm not even doing the player score right now.
Oh.
So again, let me help you guys to visualize this. This is the idea of being able to make logical assumptions about things you're doing because of how data is stored and stuff like that. So if my data, my array here of list items, we know is 100, 50, what was it again, 50, 50, right? Or
Yeah.
40, 40.
No, it's 50.
Oh, 90. I'm doing
90.
No, I'm doing the 51, so we'll do this one first. Actually, no, we can do this one first. It doesn't matter because again, we're saying if it's not equal, so.
Well, it's actually 100, 100.
Yeah. Okay, we'll do the other one first, just to make sure we do this one we're trying to do right now.
Oh, okay.
90. I kept that right there. Down a little more, so it's on top of that text. 90, 90, 80, 75. That's 75. That's horrible. There we go. 60. That's the array I'm working with. All I've done so far is create an empty list of ranked players. So this is my ranked players array, empty. I don't like putting an end list to items that are things that I'm making because I don't know how big it is. I could put the closing bracket on this one because this is set data. I'm not modifying this. I'm not adding anything to this array. This one, I might be adding to it, but it's empty. I have nothing in it.
Oh, yeah. Well,
current score, I told it to grab the first item out of my ranked array. So current score, CS, is equal to 100.
So 100 if that doesn't equal 100.
Current rank is equal to 1. And now in my code right here, I said, for each score in this item here, in my array here,
oh, I see.
if the current score, if the score I pulled, which of course the first time will be this, is not equal to R score, we already know I'm not going to do anything with it. If it's not equal, I'm just going to move on to the next one. I mean, if it is equal, I'm going to move on to the next one. I don't want to do anything with it. If it's equal to what I have, I'm not going to do anything. But if it's not equal, I can assume that it's lower, right? That is a safe assumption to make.
Yep.
Based on how the data in this array is being stored, since I'm not modifying it, and based on the fact that I was told this array is always going to be in a decrementing state, if it's not equal, I can make that logical assumption that it will always be lower. I don't have to test for it, right? I could do that if I really wanted to. I could, of course, just say, instead of doing not equal to, I could say if R score is less than current score. I could do that. But nah, we can do a little more fancy with it. I wanted to prove that concept that we can make logical assumptions based on the system. Yes, if I say in a general sense, I don't know the content of this array. If I didn't know that this array was set in a decrementing state, if I was told this array could come in any order, then I couldn't make this assumption saying if not equal, current score. It has to be lower because it could be higher or lower than in a general sense. But in this situation, with the data I'm given, I can make this logical assumption. And that's one of the things I wanted to make sure it's clear, that you can do these types of things, that you can make logical assumptions without having to use a very specific item. That makes sense what I'm trying to do?
Yep.
How that works, that's the idea again of being able to say, if it's not equal and I know this information about the data, I can say, oh, I already know it's less than. I don't even have to check to see if our score is less than, I just know it is. And so if our score is less than, I can say, okay, my current score is not going to be equal to our score. Ranked players, it's a new item, new player. I need a space there. I don't know why I did it that way. Oh, well. Or and I'm going to use the other variation of the plus plus system. So I already had it set to 1. And so in this case, what I'm going to do is I'm going to do increment first, then use. Alita, do you see this one? I wanted to do this because you see how this is valid. I don't know if we lost Alita though. Her camera went off. Oh, good. Okay. I don't know if you stepped away for a second. I was like, oh, you might have stepped away.
Yeah.
So this is the other variation where it's saying increment first, then use.
Yeah.
So this is going to change my
Yeah.
1 to 2. And then put it in the item, but it's going to permanently increment by 2. It's by 1, so it's now set to 2. Otherwise, I'm going to do nothing. This is all I'm going to do. So if it's equal to or greater than, which is not possible, but you get the point. If it was somehow greater than or equal to, I'm not going to touch anything. Then again, if it was greater than, it would try to do this. But again, we already know there's no chance for our current R score to be greater than our current score. It can only be less than or equal to. The only 2 options we have. After this, we will have a list of objects. 101, very similar to what you guys had there. 101, or how I think it was David, Jim, who had the hash map. Very similar to what that looked like. So 101. I wish I could just put parentheses like this, but again, this would be score and rank. So that's not great. I don't want to show that visual because it's gonna be a little weird. Score 100, rank 1. Next one would be score 90, rank 2, so on and so on. See how that works? That's what we've now created that. I'm going to do next. Honestly, I'm going to do something very similar to what Alita did in hers. So now I'm just going to take now I could of course try to reverse this, but I don't want to do that. So I'm going to start at the last rank. So I actually have the ending rank here. By doing the plus plus here instead of doing the plus plus somewhere else or adding it somewhere else, my current rank will actually be the last one. It will be 6 by the time it hits the end here. Or sorry, 5, I think, in this example, right? 1, 2, 3, 4, 5. Yep. So in our example, current rank will be 5. It's already at the end of my rank, isn't it? So I can just start there and go back. It's already at the spot I want it to be. It's already at the right index I want. Well, kind of -1. It's 1 higher than the index I want. That is the length of the item, right? So all I need to do next is do current rank minus, and now it's my index. My rank index. Right? See how that works? If I wanted to, of course, I wouldn't have to do the minus. I could just keep it as is and just every time I reference it, -1 by it. But I can do this. And I'm going to do, here we go. Right, list. Ranks. And I'm going to give this integer. Again, all you guys had this, the list to store the player ranks at the end. 4. We score. Score. And what do they call it again? Player. Yeah. We do those there. And again, we're going to do very similar to what Alita did. We're going to definitely do we want to loop through this ranked players list until some point. Now, some of you might have been like, well, why a while true? That seems lazy, right? Some of you might think it's lazy, but what I would say in that argument is if you can't, what you get best use for the while true, if you cannot come up with a very obvious conditional to break out of the loop, use a while true until you realize what that conditional is. Not all looping systems have a single conditional that can break it out, or a set conditional that can break it out of it. There could be varying different conditionals that could cause the break. And so that's where while true comes into play, because then you're not using the while is not the one in charge of breaking it. Your logic is the one in charge of breaking it. The big key thing in a while though is you have to have what's called a base case, something that will cause it to break out and not be an infinite loop. In this case, our base case will be, hey, if we're at 0 on our list of our ranked players list, we're done. We don't want to go any farther because that's going to be an index out of bounds. So we're going to use that as our base case. As soon as we hit the end of our ranked players and our person's not that, we're going to exit this loop. But
is there a reason why you don't use a do loop, a do while? Because you're still going to have to go through it at least once.
You technically could.
Okay.
Yeah, you could use the do while as well, but in this case, the do while versus the while, a while true has no chance of not running once. So you're not really benefiting from the do while, and then somebody else might have to, they can't see it as it's a while true. In a do while, they have to scroll all the way down to realize, oh, there is actually no conditional here. So in a while true and a do while, you're not benefiting anything because a do while will always run, a while true will always run once because there's no way for this to be false initially, right?
Right, that's true too, yeah.
With a while something, there is a side effect. There is a possibility you could technically skip it right from the get-go if the content in that conditional happens to be false. And a while true can't be false because it's true. It's a logical and possible item. So we try to be, it would be trying to say true equals false. You can't do that. That is not, that's bad. The following statement is true. The previous statement's a lie. It's false. Can't do that. Doesn't work. All right, cool. So while true, all we're going to do here is we want to check to see if our current P score is less than the ranked score we are at. If it is, we know that their rank is going to be lower than the current rank we're looking at. If score is less than dot score. Player ranks dot get current rank score. So we're getting the score of our player rank object. So this is going to return the object player rank, or sorry, ranked player. This is going to return the ranked player object. And then I'm going to access the score on it because I made score public, remember? So I can access it via the public command, via just the dot notation.
You need another parentheses on that line?
No. I have enough.
Oh, okay.
Go space
Oh,
here to show it.
okay. All right.
Space. If that helps it to see it a little better.
Oh, okay. Yeah, it does now.
If that's it, we can do, what is it? Player ranks. Add current rank +1. We use +1 because we don't want to actually increment our current rank. Oh, whoops. Thank you. Thanks, Christian, for noticing that. This is the wrong list. I want ranked players. .get. There we go. Nice catch, Christian. Glad I have the chat open. I would have missed that for a while. All right, cool. Player ranks add current rank. Good. Yeah. This is going to give us our ranked player. and then the score. If that score from the player is less than the score we're looking at, we know that their rank is one above that. You know, the logical system that we have, I don't have to check for equality. And we'll walk through that in a second, because I think some of you maybe got maybe a little concerned when you didn't, Alita didn't have a checking for equality there. We'll see how that works in a second. So bear with me for a second. All right.
I think you need a semicolon after 54.
All right. Oh, yeah, I need a semicolon, and I also want to do a break here, right? Because we found what we wanted. We found the score for this person. And so then we want to break so that we go to the next p-score. We're done with this p-score, want to move on to the next one. And since we used the rank, we didn't pass this player rank person, we want to start on this player rank again, because the next score could be lower than this person again, or it could be equal, or it could be higher. So that's why we don't want to increase our current rank, because we still want to start with this player. Our player hasn't beaten this person yet, so their next score may not beat them still. It definitely could, but it also could not. Because again, they didn't clarify for us that the player can't get the same score twice. I don't think they said that, where that the score has to be a higher score, that none of these can be dupes. I don't think they clarified that. They just said it's in ascending order, just like this one says it's in descending order. Nothing says that the player can't score the same score twice. So, where am I? Where to go? There I am. All right, cool. So we're not going to change our current rank, because we want to start with this player again, this ranked person again. Got that. All right, yeah. And since I'm using a break, I don't need an else. I actually was going to clarify that. I don't need an else because we're break. Remember, break ends all execution of code inside this looping structure and bring the outside of the looping structure. So I actually don't need an else. So from here, once I know that I'm not less than the current person, I'm going to go ahead and yeah, we can just do we'll do the if first. So if rank is equal to 0, we know that the player they're not less than the top player, because that means we're looking at the top player. If our current rank is 0, we're at the top player. And if they're not less, then they got the same, they at least, worst case scenario, they got the same score as the current player, right? So on this, there's two scenarios in this case. If they're not less than the player we're looking at, what are the two options they have?
Either the same or the
Right.
either
Less than either
equal
same,
or above.
right? No, either equal to or greater than, right? Remember that all your conditionals have an opposite conditional. So the opposite of greater than is actually of less than is actually greater than or equal to, because that's the other two options that are there. So when I'm saying opposite, I don't mean I mean the alternatives. So if this becomes false, that means the item being compared could either be greater than or equal to. That's all that means. If you're doing greater than, then it could be less than or equal to. If you're doing equal and it's not true, your item is either less than or greater than. Do that there. Is one or the other. If you're doing less than or equal to, and it's not true, then the person, like I said, yeah, is that. So there's always that parallel to them. So those are logical assumptions you can make, and you can write your code and do your solutions based on those. It's again where logic comes into place, understanding how your stuff works. But since with this now, since we know that if they're on the first player, they're not less than them, they're either equal to or greater than. Well, in the sense if the player has the same score as the first player, what rank do they get?
1.
If they're better than the current, if they actually have a score higher than the best score, what do they get?
1.
Right, so we don't have to check for equality, do I? I don't need to see if the player is equal to the top player, do I? If they are not lower than the top player, they get first place. Now they might be sharing first place or getting first place, but I don't care. I don't need to tell the system if they're sharing first place or getting first place, right? The system doesn't care, doesn't need to know if they're sharing or not. I don't need to know if they're sharing first place or they got first place. Just again, that logical assumption I can make by simply saying, hey, if they are not less than the top player, they get first place. So let's add first place. And again, since I found the rank for this score, I can break again. Last but not least, all I want to do next is do current rank plus plus. If I get to the end here, that means they are less than the current score we're looking at. They are not less, they're equal to or greater than. They are not on the top score. So I'm going to go ahead and increase my rank and increase it. And what I want to do quick is just show you how this would work on an equals ranking. So if I have the 100, 90, and 40, we'll just do these three for the moment. And my score is 90. My player got the score of 90. So rank 1, 2, and 3. I do the first thing. So I check, hey, is my 90 less than 40? Yes or no?
No.
No. So we move on, we increase rank to, or sorry, decrease. Hopefully someone would have caught that at some point. We got an index out of bounds. We decrement our current rank down to 2. 90, is 90 less than 90?
No.
No, we already know now as humans, we know that we should get second place, but we don't have anything to do that yet. So we say no here, we say is current rank equal to 0? I should be doing that as 1. Right, hold on, make sure I'm doing this right. Yes, no, I'm doing it right, sorry. Is our current rank, I should probably change this, yeah, sorry. Those are our ranks, but let's look at our indexes, sorry. Index 0, 1, and 2. And our ranks are 1, 2, and 3. Let's do that. So anyway. And now our 90 is our current rank, which is the index 0. It's not right. Our current rank is 1. So we move over again to 0. Is our 90 less than 100?
No.
What? 90 is not less than 100?
Oh, yes, it is. Yeah.
90 is less than 100. And so, oh wait, I gotta do that change because I forgot that this is, again, this is why it's good to do these kind of like walkthroughs with yourself, because I just realized because my current rank is indexing, I need to do +2 here. Because I'm doing indexing. So current rank +2, because I need to go from 0 to 2, because my 0 is representing 1. So yeah, current rank +2. Yeah, that would put me at second place, right? So this is how I don't need to check for equality. Can I add that in there to make it very obvious what's happening? Of course I can. If I want to make sure that I can add in somewhere in here, if equal to, add the current rank +1. So for those who are a little lost on that and aren't sure, if you felt the need for it on this one, we could always do if a score equal to rank players dot get rank dot score player dot add current rank +1. So that it's this, they get the same rank. I could also even just, instead of doing current rank, oh, I see what I'm doing, dumb. I'm showing you the index thing. I wanted to do,
Because I was thinking if it goes any higher, like if it was place 2, it would go to 4.
hold on. That's what I meant to do. Current rank dot rank +1. That's what I'm doing, dumb. This thing, I'm supposed to do this. There we go. Rank players dot get current rank +1. So I get the rank of the player we're looking at. So one thing I also might want to do just to make this clean is to do rank player equals rank players dot get current rank. So that way I can just do RP. I can just do RP dot score, RP dot rank, RP dot score, and RP dot rank. There you go. Oops, I didn't mean to hit the Control S, Command S.
Although that's cleaner, does it take more memory to store it in a variable?
Not this much. Like it's probably not going to set. Again, this would be definitely yes. It is taking more memory, but what I would be doing arguing is saying I'm saving by not having to do the dot get multiple times. So you saw there, I was actually ended up doing a get here, a get here, a get here, and a get here. So I was doing 4 gets. So that process might be slower. And so saving it by so I can do the rank once, yes, I'm taking up more memory, but I'm reducing the amount of processing by having to run that dot get multiple times. I
And
did
it
dot
looks a
get
little
once.
cleaner too.
What's that? And it
It
looks,
looks
a little cleaner.
cleaner too.
So yeah. Now in the original thing where I didn't have this in here, since I was only running the dot get twice, that's something where you could argue maybe it's not a big deal. Maybe if I wanted to save memory, then yes, I would do the dot get twice. But depending on, do I want to save many memory or do I want to save processing? In most cases, we want to save processing. But if you were writing on something that didn't have a lot of memory, then you might not want to do it. But yes, this saves processing by using memory. That makes sense?
Yep.
All right, cool. Good question. And that should technically work. Ranks. Let's see. How many semicolons did I forget? There's one. Where are you? I thought I could see it quick. Nope. Where is it?
Line 44.
44 and 45. Yep, there's 1. And there's 2. Yeah, let's try that again. Using the file while parsing. Should enough. Yeah, semicolon or something. Let's see. Good. Good. You'll read through my code with me, see if you can see anything wrong with it. Let's see if you see it before I do. That should tell me that I'm missing, most likely I'm missing a semicolon or a parenthesis or something. If I'm hitting the end of the file, it's usually because I have some sort of mismatched parentheses.
How about your while loop? Oh, is your while loop right there? Yeah. Oh, yeah. There's the end of it. Okay.
That one, yeah.
And what's the one underneath
one.
that goes? Oh, that goes to the for loop. All right.
Yep. That one. Parenthesis.
Is there should be a second one underneath the return, or is that the bottom one? Does that go to the?
It should go all the way up to this one. Yeah,
That one. Okay.
Exact list.
How about
Hold
the?
on.
Is there
Wait,
something
hold
above
on.
that one?
Hold on. You think you might have me be onto something? Why is my code's all indented wrong too? So yep, I am missing a semicolon there because this is all indented once. So I had what Alita had because yeah, they put their friggin' comment unindented. So Alita, it wasn't entirely your fault. It was HackerRank put their comment on the wrong spot. So I started my code there too. So yeah, there should be an item here because this should be getting rid of the class result.
Yeah, and not only that, they put tons of comments above the class, so you don't even. It's just.
Yeah. But these comments are in the right indentation. So see, they're not even being consistent now. Damn you, HackerRank. These comments are indented correctly. This comment was not. Way to go, HackerRank. All right, so that's why, yeah, I was missing a semicolon, or yeah, missing a curly bracket. There we go. Anyway, they passed. Submit it, and we'll review the code again and make sure it makes sense. Boom. Congratulations, you solved the problem. Yay. Wait, I'm 3-star. Nice. I'll get my 4th star soon. No, I need a lot more points actually. Never mind. So, all right, to make sure it makes sense again, we created our object. We built a list of that object, went through and created the data. So we saved it. We made sure for each score, we gave each score rank and we removed any duplicate scores because we don't care for those. Taking advantage of logic, we were able to say, hey, if our current score is is not equal to our score, we know that that new score is lower. So we can only add it though, and we only add it to our list if we see a lower score. Because again, we added the first score already. So we already added the first score. That's why I did this, so that I could take advantage of this kind of feature by saying, hey, and this way it'll automatically skip the first item. That was the other reason behind this. By doing it this way, I grab the first item, I use that as my starting point, because numbers, we know in Java there's no null or undefined, there's no null in, or even undefined numbers in Java. If you create an int and you don't make it equal to something, it starts at 0. So you can't use, so you gotta be careful with that. So by doing this, we started it somewhere, we added it in. Less than, we add that in, we add our rank. We knew that our rank would then be the length of our current rank would be the length of the array. So we just use minus minus to make it our index. We then create our player list, player ranks list to store all the ranks the player got from beginning to end. We loop through all our player scores with p-score. Every time we go through, we pull that player that we're looking at right now. We pull the player we're looking at. We say, if the player score is less than the ranked player score, we know that we're done. We know where this person is now. Because we started from the end of the list in the beginning, we know exactly where we are. So we're at the end of the list in the beginning. If our player is lower than that, they're one place below that person. If they are not lower than that, we need to make sure, well, is this current player we're looking at the current leader? If they are, they're automatically first place. Whether they're the same or not, whether they're the same or greater, they get first place. We were not asked to tell them whether or not they're sharing a position or not. We were just told, get us the rank of the player. So that's why we don't need to check for equality there. Otherwise, we're going to move up to the next player and do the same process. If they're less than that person, then they get that person's +1 rank. And this is how we can also handle for that dense ranking system that we mentioned. If I'm the same as if I'm equal to the person I'm looking at, once I move up to the next player, that will send me back 1 position. So that's where this works. Again, if it's not clear, I can add in that extra conditional saying, hey, if I'm equal, give me the same rank. I can put that here or here. Doesn't matter where that goes. I can check for equality if I want. But based on how the logic of the data structure, of how the data is structured, I don't actually have to explicitly look for that. This system will work. And I can test that. Like I said, I use the annotation, I use the whiteboard, and I can test to say, will this work? Yep, awesome. Okay, I can use this. I don't need the equality. I can also see here that there are 2 ways that when I'm breaking out of this loop, this way and this way, but I want to do certain things when that happens. So this is where the while true becomes very, very effective here. This points out to me, yes, while true is the best thing to use because there's 2 reasons why I may want to exit this while loop, and they're not similar. They're very, very different reasons, and regardless of whatever the reason is, what I do when that reason occurs is going to be different. So p-score less than our p-score, yes, it's going to break me out of the while loop, but I need to do this. If my current rank is equal, yes, that breaks me out of the loop, but it does this instead. It does a different behavior, and that's where while trues become very useful, because that means you control when the break occurs, but you can also do certain things before you exit the loop. And if those things are different, then you can do that. If the things you're doing before the break are the same, you can actually put them outside the loop. So check on those things. If the things you're doing before your break are exactly the same, they can drop outside the loop.
So when does while become false?
Only when you hit the break. And
Oh,
this is
so
our base
could you
case.
use- well,
This
could-
is preventing us from getting an integer overflow. We will check for our current rank, our index to be 0 before we deduct from it. And if it is, we break. So we will never hit a minus minus and bring our index to -1. Our index will never hit -1. As soon as our player starts, once this player hits this true once, it will always hit true on this. And that's something sort of logic I could state on that, is that I could always hit logic on this. Once this hits, I could do that. So that's an interesting thing to do. But anyway, any questions on this?
No, the only just one is just like I mean, I understand why, but it just seems like 59. You're using a magic number because you're adding 1. But I understand why.
Right.
I understand why it's doing it, but it seems like it's just like you're assuming that it's 1. But I understand why you're doing it though.
Yeah, I could do that. But yeah, I could do that. And at the same time, I can always just create a constant variable somewhere that calls it, what's the word I'm looking for?
Oh, wait. Oh, yeah.
I could create a constant called first place somewhere at the top and give the number 1 there. So, but in this case, I think it's fairly clear what we're doing. We're doing player ranks first place.
Yeah.
Since the variable name kind of makes sense, it kind of makes sense what we're doing. So I think that magic number works. A good quote, good use of the term magic number. Any other questions? Good. One thing I did want to showcase again, though, just to kind of clear this up, by the way, where I think I can make things a little interesting. Like I said, I noticed this afterwards, after we did our walkthrough, and this is something that can happen later on. Conditional logic doesn't always give you the best solution. I did realize later on that if we did the dupe removal, as you saw there, we can just use the indexes. And so what I could do here, instead of using an object, I could just, as you saw, go through and clean this up, either using Evan's set system or David used the hash set system. Both of them used ways of deleting all the items, and I wouldn't need to keep track of the ranks because my indexes would be the ranks -1. So then I would just have to loop through and just take the index and do +2 here and 1 there. And that would give me my numbers too. So I could always just do right here, rank 2, and this will still work. Watch the code. Still functions. And this would then be able to let me know, oh, I still have more refactoring I could do if I wanted to. I don't need to track the rank because I removed the duplicates. Make sense? So there is still some way you could actually even improve on this too. This works great. It solves within the time frame, but even on my solution, there's still ways to improve on it. Once you go through the solution, you could see more ways of solving it. We will realize that the index could be used for our rank. So just be aware of those things. Those things are pretty cool. They're interesting tidbits of information. So at the same time, I could also just do current rank and right here do current rank -1. And I can do current rank -0. And that way I can just do current rank +1. So that'll work too. So there's multiple ways you can deal with this and work with it. Multiple things you can do to make this legible, readable. If you want to work with it, it's all based on logic, using both computational logic, but also just logical reasoning too. And so one other tip I can give for some people, maybe this is why I have a slight advantage, because when I used to, was it back in like 2006, 2007, I worked up in Boston, but I was living in Warwick. And so for several months, my commute was to wake up in Warwick, go down to a bus and take a 1-hour bus ride from Warwick Neck to Providence. I would then get off the bus in Kennedy Plaza, walk up to the train station and take a 1-hour train ride from Providence to South Station, Boston.
Sounds
and then take a 10 to 15 minute, about a 10-minute, subway ride to Boston Commons, and then walk up to my job. Then I would do the same thing home.
That sounds like me.
Yeah, this again was back in 2006, 2007. Cell phones then were not able to play the games we play now. And so I actually would grab these logic puzzle books and use these. And what these items do is they give you a list where you're supposed to figure out Amber, let's say for this one, most likely Amber, the last name, and then what they wish for. 6 leprechauns. Oh no, one of them is the leprechaun, and one of them is the child, and what that child wished for. So this is saying what the child wished for and which leprechaun. Let's see. Hold on. Let me figure out. Okay, so these are the leprechauns. These are the children, and these are the wishes. And so your trick here is to figure out what did the child wish for and which leprechaun gave that item. And so in this one, very quickly, we'll just do a couple very fast here to see what it looks like, how you solve this. So neither David or Izzy got their wish granted by Lucky. So David and Izzy, we can put an X on Lucky. Already know that. And so if we ever found out what Lucky gave, so if Lucky gave the money wish, we would automatically be able to say that neither Izzy or David wanted money, right? We could make that logical assumption if we found that out. And that's what this puzzle gave us for this. That's what this puzzle helped me learn. Can I make assumptions based on non-explicit statements? Can I figure out information based on what I know that was not explicitly given to me? Again, George wanted the wish for good grades. So George, where's George? Oh, George right here. So wait. Oh, George granted the wish for good grades. Check that. Oh, that's an eraser still. Either Sarah or Sam wished to live in the castle. So Sarah, castle. Oh, hold on. What I can do there is cancel everyone else. So Sarah and Sam. So Nick didn't, Izzy didn't, David and Amber did. So either Sarah or Sam did. Let's see. All Nick could think about when talking to Freckles was buying a bunch of video games and candy. That's a weird one. Can't even see it. Again, same thing you can do here. So this is telling me that Nick probably wished for one of those two. Most likely Freckles. And this is something I would hold off on to say right away, but I would probably say Freckles might have done one of these two. He might have wished that item, since apparently the leprechaun talked to the children's. It says here Nick talked to a leprechaun. Okay, not the best example maybe, but you can see how the process goes, right? Slowly but surely, you'll figure out what did each child wish for, and who granted the wish, so which child they work for. And through this logical reasoning, you'll be able to figure all these items out, and you'll be able to make deductions that aren't explicitly given in these bits of data here. And this is how you can find information that isn't given to you blatantly. This is something I used to do a lot on the train. On my train rides to and from Boston. This is one of my favorite puzzles to do. So something to think about if you struggle with this kind of logical reasoning and stuff like that. It may not hurt to look into these and maybe try them out.
It's funny.
What's that?
That's funny. That's funny that you say that. I have moving on to the second round of the process and interview, and I asked you about your researching thing, like to see what they're doing. They use Python, and I found a project I found is making one of these boards, and it's making like one of these boards, and like the Python system, like I don't know, figures it out on their own, but just to show off like your use of logic and computers and stuff like that. That's very interesting.
Yeah. This is the thing I used to do a lot of. It really helped me to just grow my logical reasoning and being able to make assumptions without being explicitly told things. And that's why, like for me, again, this idea that if the score isn't equal, I can state, yep, nope, it's going to be negative. It's going to be less than. This is one of the things, like, it didn't need to be told to me. I knew that because the data was in a descending order and my current score is going to at least be the first item, that if they're not equal, it has to be less. Nothing had to explicitly tell me that. I was able to make that logical deduction based on what I knew. What I was given, I was able to make that. So something to consider. Again, these are just, what I'm trying to give you guys are just different things you can use to level up the skills that developers use. These are skills that developers benefit from. Not all the skills are coding. Do I still have that research article?
I went from East Providence to Boston when I worked up for a computer technician. And I
hold off on that because Alita's about to leave. It's almost 9 o'clock and I want to make sure I get this last little bit out there. I'll try to find the research article to share with you guys later. But when it was a while back, HackerRank does a yearly release of what the skills are that companies are looking for. What skills do they rank out of a score of 100. When they did that, the score with a 98 percentile of 100 out of all their employees, they want 98% of them to have this. It was not language. It was not programming language. It was problem solving. Problem solving and that kind of stuff is the top skill they want. Programming language came in at a 60 percentile. They almost wanted problem solving twice as much as they wanted programming language. Twice as important. Problem solving ability is twice as important as your ability to actually program. So that's why things like this, like doing these solving problems, algorithms are key. Doing logic puzzles can be helpful. Anything that helps you to just think and process information and solve problems is going to benefit you. Sound good?
Yeah,
So-
I do crossword puzzles, but I mean, I know that those are a little bit different, but I
Yeah.
do those constantly.
Yeah, next time you're at whatever, next time you're at like the gas station or something, if anyone goes there, check and see if they have one of these, or like the CVS or something. Usually like CVS or Walgreens, the magazine section. You might find one of these. If you see one, pick one up. I think I actually have one in my closet.
I wouldn't be surprised
So-
if there's an app for that. For
There
that.
probably is, yeah. I just get nervous about the auto-generated ones because then I'm worried how it might sound and work. But you can always try them. Let me know if you find a good one. But I will say, if there was another one I can point out. Last one I can say before anyone goes. This is another one that's very similar on it. It's just
Oh, I
number
did these.
based.
I used to do these
Yes.
all the time.
These are very similar. You're using deductive reasoning to decide what dots are
Yeah.
colored in.
Those are fun.
So these are also logic based too.
And you could get ones that are in color. So you do 3 colors on this one and make color ones. The
Yeah.
color ones are very interesting.
These you can easily find mobile apps for.
Yeah.
There's tons of mobile apps for these nonograms. Just search for there's tons of them out there.
Okay.
There you go. Yeah, multicolored nonogram.
Yeah.
There you go.
I love these puzzles. I love doing
Yeah.
these. These are a lot of fun.
Also logic based. You have to use logic and deductive reasoning sometimes to figure out which dots are colored in, which ones aren't, because of, well, if I have 10 available spots and 9 of them are colored in, well, it's either the last one or this one that's not. So in a row of 10, but these are some tools you can use to improve your logical reasoning, deductive skills if you can't get to coding. If you can't get on a computer, if you can't code, passenger seat in the car, sitting on the toilet, stuck in a waiting room at a doctor's appointment, whatever. Sudoku is good too. Yes, Alita. Sudoku is also very good. Yep. Anything that challenges you to think and make deductive reasoning, that's going to benefit you. So dive into those. If you've never done one of them before, dive into them now. So again, the main goal is to try to continue raising those skills that computer scientists benefit from: logic and deductive reasoning and problem solving. So nonograms, logic puzzles, Sudoku, those are all great. So definitely make sure that if you can't get the code, you can't do the Enki app, do a Sudoku puzzle, do a nonogram, find a logic puzzle to solve. Those are going to benefit you greatly, getting your ability to deduce and do deductive reasoning and solve things in a logical way. Sound good? Nice. So for Thursday again, the organizing balls, get that one going, organizing containers with balls in them. We'll go through those. We're gonna do the same thing we did today, showcase a couple examples, and I'll go through a solution. Get help if you need it tomorrow. Post in there again. If you need to, at me, I'll do an @channel, then just start a Zoom meeting and see if anybody joins. You don't have to wait and be like, does somebody want to join? And then start a Zoom meeting. Just start one sitting there by yourself, doing your work by yourself. If someone pops in, great. So I used to do that. Like I said, when I was in class, I would sometimes go to East Providence to do a study session. And there were days that somebody didn't show up. I just had a couple wings, solved some code there, and then went home. But about 90% of the time, at least 1 or 2 people would show up and we'd work together. So
we just you know, Cliff, we were in a Zoom meeting yesterday till like 11 at night.
I know we were.
awesome.
Me, Evan, Jim, and
Did I miss that Zoom
Yeah,
link?
we were.
I don't remember seeing you guys post that.
It was actually your meeting.
It was your meeting.
Oh, okay. You guys just stayed in that
11.
meeting longer. I was gonna say, okay, cool. Do
Yeah.
that again. By all means. Hell, if you guys want to stay on later tonight, I'll even make one of you guys a host and you can keep doing it. I don't care. And that's another thing. If you want, if I'm not using my Zoom, I'll gladly give you guys the Pro Zoom. So if I see that and you're like, hey, we got a bunch of people here, Cliff, can you give us the Pro Zoom? I'll be like, sure, if I'm available. I'll jump in and activate it for you guys and just make one of you guys the host. So I am here to support you guys in your learning process. All right. Any
Okay.
other questions? All right. You guys know what you got to do. Do your demi course, do the organizing balls, and try one of these once in a while. If you just can't get into code, if you're just not feeling it, solve a puzzle. All right. I'll see everybody on Thursday. Have a good Wednesday.
All right, see you.
Take care, everyone. Bye.